Welcome back, everyone. This is the continuation of 10.1. We just looked at this in the last video. We looked at this previous example. So today we're going to start with this show you know question. So it says point C is the center of the circle DAB. Here's the center of the circle. DAB is 55. What are the measures of DEB and DCB? As well, you need to justify your answers. Please pause now and give it a try. Now that you've had a chance, here are the answers. If DAB is 55 degrees, which the question gives us, that means that DEB also must be 55 degrees because they are both inscribed angles with the same endpoints. They're both formed by two chords, and they both have the same endpoints, D and B. Therefore, they are both inscribed angles. The angles must both then be equal. DCB, on the other hand, is a central angle with the same endpoints, so its measure has to be double, so it will be 110. In example 2 here, we have to use central and inscribed angles to recognize relationships. It tells us that point C is the center of the circle. This time it's giving us side lengths. AB is 10 centimeters, chord BD is 6 centimeters. We have to say what is the measure of ADB right there. And we also have to give the measure of the chord length AD. Now this one's a little bit different, but if you stick to the rules that we learned in the last video, you should be okay. So we need to start by determining the central angle. The central angle is right here, ACB. ACB is the central angle. Even though it's a straight line, it still is the central angle. The measure of a straight line, of course, is 180 degrees. So if 180 is the central angle, then the inscribed angle here, ADB, has to be half of that. So this angle here is 90 degrees. Okay, so anytime you see a central angle that is a straight line, it's a pretty good hint that the inscribed angle then is going to be 90 degrees. Now, for part B, we have to find the length of chord AD. At this point, we have to use the Pythagorean theorem, because we have this is 90 degrees, the hypotenuse is 10, and the side length is 6, so we have to find this other side length. The Pythagorean theorem, remember, is a squared plus b squared equals c squared. The c is the hypotenuse, which is 10 squared. A and b, which you call them, doesn't matter. We'll make this 6 squared and make this b squared. 10 squared is 100. B squared is b squared. 6 squared is 36. To solve for the b, we have to subtract 36 from both sides. So we get b squared equals 64. And then to get the b by itself, we have to take the square root. So b is 8 centimeters. Okay, so the length of chord AD is 8 centimeters. Using that same knowledge you just gained, please try this question yourself. You have to give the measure of ADB, and then you have to give the length of AB. Please try that now. Now that you've had an opportunity to try, here's the answer. Once again, ACB, the central angle, is a straight line. The measure of a straight line is 180 degrees. So the inscribed angle has to be 90 degrees, half of 180. If this is 90 degrees, then we have a right angle triangle here, so we can use the Pythagorean theorem to figure out the length of AB. Once again, a squared plus b squared equals c squared. And this time we're trying to find the hypotenuse, which is AB. So this is our C, this is our A, and that's our B. 12 squared plus 5 squared equals c squared. 144 plus 25 equals c squared. Add those together is 169, and take the square root of c squared and of 169, and we get c is 13. All right, now that we've looked at those examples, I'd like you to try this assignment, page 382, 3 to 10. If you have any questions, please leave them in the comments or send me an email. Thank you.